And then after that will be
-8, -5, -4.
okay. So for the B matrix will be just answer straight. Okay, I
0,
just
0,
write
1.
0, 0, 1. Okay. And then for the Y matrix, for the C matrix, sorry. At this part. For the C
3,
matrix.
1.
Yep, once again.
3, 1.
3, 1 must be have another
0.
0, 3, 1, 0. Okay. For the OCF, for the OCF part, firstly need to fill up this one from bottom to top. So this one will be what value? At this part.
-8,
-8, and then after that,
-5, -4, 0.
okay, only because this is 3 by 3 matrix. Okay, so after that we move to this one for the most right. Firstly, we just need to fill up the most left. After that, we just need to move the most right. Okay, after that, this one will be what? 0, 1, 0, and after that, Sean? 0, 0, 1. Okay. Alright, so for the B matrix, what will be? We need to fill up from the bottom to top, start from here. For the B matrix, we must read from left to right. Right to left, sorry. So it will be 3, 1, 0. Yeah, this one 3, 1, 0. Or in the right way, 0, 1, 3. However, you must know the combination. And then for the C matrix will be starting from here. Starting from here. 1, 0, 0. Okay. Alright, done. To convert from the to the PVF and OCF. So if you know how to convert these, then you are okay to design the pole placement and observable controller. Okay, so this is the most important step for you to design these two controllers. Done. Okay, so now done for converting this part. Okay, so far we already discussed how to convert the state space to transfer function and how to convert the transfer function to state space. Okay, however, I only discussed two forms only, PVF and OCF. However, the other three, I will fill up the slide and then you can refer how to convert from the transfer function to the other three forms. Okay, so now this one, this one, this one, this one. Okay, so the most importantly is itulah. If you want to design the pole placement controller, you must use the phase variable form. If you want to design the observable controller, you must use this observer canonical form. Alright, then. Okay. So before this, when we want to convert this form, something like this diagonal form example. If you want to convert this form to this form in this previous explanation, you must know the transfer function. You must know the transfer function, and after that, from the transfer function, you only can convert to this form. Okay, from the previous. Okay, so if you want to convert from state space A to state space B, you must have the transfer function. Okay, however, you also can convert from the state space A to the other form, example like this, without using any transfer function. You can convert them without using transfer function conversion. So that's why we learned about the similar transformation. Okay, in the previous topic, the system can be represented with different state variables even though the transformation relating to the output and input remains same, and the system are called similar system. We can transform between similar system from one set of state equation to another without using transform function and signal flow graph. So you can do the shortcut way. Alright. So from the state space, you can transform into the different state space. Okay, the process is a transformation. This one actually both of the state space actually will give you the same output. Same output with same input lah. So it means that if you simulate this form state space and you simulate by using MATLAB this state space, you will get the same answer, same output. Okay, so this is what we call as a transformation. Only the form only different, however the system itself everything same. Okay, so let's say if you run this system using the Simulink and run the system using the Simulink, you will get the same graph output. It's not different at all. Only the form only different. Okay, so to convert from state space to transformation state space, you can see that X normally in the textbook you use this symbol lah. If X, it just do the symbol of Z. Okay, just replace A. You change to A hat here. So every X need to change to Z. Okay, every X change to Z. Okay. For the A, B, and C matrix, D matrix, you just need to put the hat here. So what is the formula for the A matrix? A hat matrix, this is the formula. A hat matrix is T inverse AT. The B hat is a T inverse multiplied with B matrix. C hat equal to C multiplied with the T, and D hat actually same equal to D. So now, in order to calculate A hat, B hat, C hat, and D hat, okay, you must know what is the T value, T matrix. Okay, you must know the T matrix value because we already have information of A matrix, B matrix, C matrix. The only we did not have the information is a T hat value, a T value matrix. So now the crucial part is to determine the T value. The T value can be obtained from the eigenvectors. So that's why in this subtopic, you will learn about the eigenvalues and also the eigenvectors. In order to get the T, and also to get the A hat, the new transformation. Okay. So firstly, we go to the eigenvalues. Okay. I can conclude that the eigenvalues are equivalent to the poles, where both parameters can obtain from the characteristic equation. Okay. When I do some review on the previous class, I told that the characteristic equation is based on this characteristic equation. Okay, from the determinant of Si minus A. Okay, so from determinant Si minus A, you can obtain the poles. Okay, during I explained to you on the previous class. Okay. So for the eigenvalues also, because the poles actually similar to the eigenvalues, I put EV lah, eigenvalues. So that's why you just use the same information. Okay. Normally for eigenvalues, S is replaced with lambda. Then the formula to calculate the eigenvalues is delta lambda I minus A. Same thing lah. So this example lah. Okay, find the eigenvalues of the matrix A. So we use the same formula, determinant L I minus A. Same thing. So firstly, you need to find the lambda I minus A equal to what? This is lambda. I is the identity matrix. Since this is 2 by 2 matrix, your the identity matrix will be 1, 0, 0, and 1. Okay, minus with negative 3, 1, 1, minus 3. Okay, and then after that, you solve lambda I minus A, you got lambda plus with 3. So this one will be negative 1, lambda plus with 3. Okay, so finally from the answer from the lambda minus A, you calculate the determinant of lambda I minus A. You have the answer is lambda square plus with 6 lambda plus with 9 minus with 1. And finally, you got lambda square plus with 6 lambda plus with 8. Same thing with the poles. Same thing. And then you factorize everything, you got lambda plus 4 lambda plus 2 equal to 0. Okay, so that's why the answer is negative 2 and negative 4. That's the eigenvalue. So the eigenvalues actually equal to lambda 1 equal to negative 2 and lambda 2 equal to negative 4. So this is the answer. Easy. Okay. Next. So now we go to the eigenvectors in state space. Okay. The eigenvectors of the matrix A are all vectors which under the transformation A become multiples of themselves. That is. Okay, this is the formula for the eigenvectors. Okay. Any vector that is collinear with new basic vector are similarity transformation to a diagonal system. So in this case, because you can see that AX here and X is not on the same line, it's not on the same line. So this is not an eigenvector. This is the meaning of the eigenvector. So if the X here is same line with the AX, and then this is an eigenvector. So X here actually refer to this thing. AX refer to this thing. Okay, so the only parameters then can make X and AX on the same direction of vector, the lambda I value. Lambda I value, the parameter that move the X here become the same line with the AX. Okay, so now how we want to calculate eigenvectors. Okay, the eigenvectors, you need to use this formula. Okay, so you can see that this question is similar to the previous similar. Okay, from the previous example, we know that our lambda equal to -2 and -4. So we know that lambda 1 equal to -2, lambda 2 equal to -4. Okay, so now we look at this equation, this formula. So since we have two lambdas here, so you will have, where is the mouse? Okay, because we have two lambdas here, so you will have a x1 equal to lambda 1 x1, and then you have a x2 equal to lambda 2 x2, right? Okay, so now because you need to solve two equations here. Wait a minute. Hello. Alright, so this is actually referred to x1. Yeah, so this is referred to the x2. Okay, so we need to solve one by one. Firstly, we go to this one. So a -3, 1, 1 minus 3. You have x1, x2 equal to, okay, dan lambda 1 equal to -2, x1 and x2. Okay, so you solve this -3, x1, you solve it. Wait a minute. Share screen. Okay, so we go to this part. Okay, according to this part, we have a actually equal to -3, 1, 1, -3, and then the formula is a x equal to lambda I x. Okay, and then after that, we know that based on the previous answer, lambda 1 is -2, lambda 2 is -4, and then we use this formula. We got -3, 1, 1, -3 will be x1, x2 equal to lambda 1. The first lambda is x1 and x2, and you solve it, -3 x1 plus with x2 equal to -2 x1. This is for the first equation, and we solve it, become x2 equal to x1. Okay, then for the second, this is for the first one, and for the second, we solve it, x1 minus 3x2 equal to -2 x2, and we solve it, x1 also equal to x2. Okay, so we can conclude that we can choose any value you like. If you select x1 equal to 1, hence x2 become 1. Okay, because our conclusion we got x2 equal to x1. So if you select x1 equal to 1, then you get x2 also equal to 1. Okay, same thing applies here. So as conclusion, you can say that for the first part here, if you select x1 equal to 1, x2 also equal to 1. So you got 1 and 1. Okay. If we refer to lambda equal to negative 2. Okay, now we go to the second part. So now we go to lambda 2 equal to negative 4. So finally, by using this one, we got negative 3, 1, 1, negative 3, x1, x2 equal to negative 4, x1 and x2. Okay, you just plug in everything, negative 3, x1 plus with x2 equal to negative 4, x1. You solve everything here, you get x1 equal to negative x2. Okay, for the first part, for the first. And then we go to second equation. We got x1 negative 3x2 equal to negative 4x2. And finally, also you get x1 equal to negative x2. So in conclusion, if you select, you can choose any value. X1 equal to 1, then become negative 1 for x2. X2 equal to negative 1. Okay. So that's why, in conclusion, you can say that if lambda 2 equal to negative 4, this is the value. If you lambda 1 equal to negative 2, this is the value. So in conclusion, your eigenvectors is 1, 1, taken from here. Okay. And then after that, taken from here will be 1, negative 1. So that's why in your answer, you get the eigenvectors. We name the eigenvectors, the symbol is T equal to 1, 1, 1, and negative 1. Okay, so this is how you get this answer. Okay, so this is for the eigenvectors. The symbol of the eigenvectors is T. Okay, so when you know your eigenvalues, and also you have your eigenvalues, and also you have the eigenvectors, then you can find the similar transformation state space. Okay, so in this case, you want to convert this state space to diagonal form, diagonal form. Without convert this state space to transformation, you want to convert straight away to this answer. That's why we use transformation state space by using this thing lah. Okay, so you know that the A hat, this is the formula. B hat, this is formula. C hat, this is formula. D hat, this is formula. So actually this is referred to A hat. This is referred to B hat. This is referred to the C hat. Okay. So if you can see that this is the same A matrix according to the previous. Negative 3, 1, 1, and negative 3. Okay. So the only formula to calculate the A hat, you must know the T. This is the formula, T inverse NT. So, however, according to the previous example, you already calculate the T matrix, the T matrix. So this is your eigenvectors. Actually, for the T that you must use to solve the A hat value to get the A hat, B hat, C hat value by using this T. 1, 1, 1, and negative 1. Okay, so in this case, you need to calculate lah to find what is the T inverse. T inverse, and T inverse will be 1, negative 1. Dia punya tu, saya forget lah. Control Z, tak boleh Z, Control Z. Then after that, you need to find the T inverse and so on. So by using this, you can see that this is your matrix here. This is your matrix here. And then by using the transformation, you can get the diagonal form. This is diagonal form. Why diagonal? This is, you can see this is diagonal. Diagonal. The rest will be 0. Only the diagonal part have the value. Okay, only the diagonal part have the value, the rest will be 0. So this is the diagonal form. The diagonal form you can use to different application. Okay, so that's why you learn about the transformation. Okay, similar transformation for the state space. Okay, so this is why you learned about convert from the transfer function to state space, because you want to apply the system to different application. In this case, you want to implement the controller, pole placement controller and observer controller. So that's why you learn to convert from transfer function to state space. And then after that, because of this, after that, you also can convert from one form of the state space to the different form of the state space by using the similar transformation method. Okay. So this is the output lah, the objective that you learn today. Okay, so if you don't have any question, hopefully you can try to get this answer lah. Calculate. You already have your T, just calculate the T inverse. And then after that, try to find the A hat, B hat, and C hat. Okay? And see if you get the same answer or not. Alright? Okay, so for your information, you can find more examples and exercises at this textbook. Just click this link and then you can do so many exercise example for control. Okay? Just refer to this textbook. Okay, before we end the class, any question regarding to this topic, today's topic, or others lah? Do you have anything?
Doctor, for the OCF, how do you get the Y matrix again?
Y matrix again, the C, C matrix.
Yes, yes.
Okay. For the C matrix, where is it? For the OCF or CF? No OCF. Okay, OCF for the C matrix. Kita besarkan. For the C matrix, for the OCF, you must follow this pattern. This is the pattern lah, you must know.
You're not presenting
1,
anymore.
0, 0, and so on. So let's say if you have a 2 by 2 matrix.
Doktor tak present pun dah.
Tak present I need to present. Share. Ini dah ada kan?
Yes.
Okay.
Right. Saya nak buka ni satu screen nak check. Okay. For the symmetric for the OCF, you must remember this pattern. C 1 0, the rest is 0 lah. So let's say if we have 2 by 2 matrix for the A, your C will be 1 0. If you have 3 by 3 matrix of A, your C will be 1 0 0. Okay, so it means that according to the PVF kan, PVF, the B matrix, the pattern here is 1, the rest will be 0 kan. However, for the OCF, dia terbalik. Okay, opposite. For the OCF, the pattern of B, actually we put at the C matrix. Okay, we swap. Okay, clear about that?
Yes, Doctor.
Alright. Another question? Okay, so hopefully you understand the concept why I teach you why we need to transform the transfer function to state space to different forms firstly, and then you must know the concept lah why I teach you the other way, the method to convert from state space A to state space B. Okay, however, when you run the summation, you get the similar output. Alright. So before I end the class, I need to make one thing. Please bear with me. Apa benda dah? Okay. Kejap Yeah. Sekejap. Question. Okay, before you leave, I would like to give you an announcement regarding to your test. Okay, regarding to the test. Okay, your test one, I will conduct on 30th of May 2022 during your asynchronous session. Okay, the test will be 8:30 p.m. to 10 p.m. Okay, so this is the duration of the test. So the test will start on 8:30 p.m. to 10 p.m. on the next 2 Mondays on 30th of May 2022. Okay, so this is your test one. Okay, so hopefully you clear about that. So before you leave, as usual, I will send the attendance links. So please find the link in the chat box. If you don't have anything, you can leave the meeting. If you have any, I will wait here about 5 to 10 minutes to answer your question. Thank you so much for your attention.